Hello? This is number 6? Oh my gosh, a bit of a delay between those last 2 days. I was lazy. I gotta get it together. Actually, really lock in for this stuff. But, today, and I'm gonna move myself. I'm gonna be over here. So, what I've done the last 2 days, is implement, falling off the map and portals. So I think my last update video, what was I doing? I was shrinking the map, cutting it away. And you can see that we've made a few changes since then. So this is the Unity editor. There's a bunch of different stuff in here that's kind of in the way. You can see these gizmos, so I'll just hide those. But what I've done is now, let's get the lobby, Torus, no, characters. There we go. So the whole gizmos. So these, you can see these rings. These actually are little test things for the like the cutting of the map. I'm just gonna hide. I don't think I can hide that anyway. Alright. So yeah, these are the test things for cutting the map. You can see that if I move them around, there's these lines that are cutting through the map here. These are where the first seams are going to first appear. So this is really handy, and I can demo this, because when I was playing the game with what I'd implemented so far, it was really hard to tell where the safe spots were, right? Because the idea is that I want these rings to close in on spots where the like 3 spots where you can choose to fight a boss, right? But that wasn't really working too well, because you'd suddenly just randomly be cut off, and you had no idea how to like predict, okay, this is how the map is going to get shrunk. Because this shrinking on this object, it's really hard to wrap your head around exactly like how it's going to behave when you can't see like the outline for these things themselves. In fact, I think this is going to be a good demo, because I don't know how this is going to behave. So if I shrink these, right, you can see, okay, on the left there, if we go over to this, the map, so as these spheres shrink, and I'll show them, we've got 2 spheres over there that are kind of clipping through, and so they're closing in, and they're slicing through that section of the map. So that's why that line is there. And the same thing is going to occur for this one. So this is going to be this hole over here, and probably this one over here. 2 of those probably. And so we're going to see the same thing occurs again. So there's now there's like a new like front to the slice that's going through. So that's pretty handy. And it looks really good on the mini-map. So this map that we're looking at right now, this is actually the mini-map view. The actual view doesn't have this silhouette that I also added, so this little transparency. I think this works really, really well, especially in game, which we'll go to in a second. And so that's really cool too. And if I'll go over exactly how I implemented some of these things in a moment. And if anyone actually does see these videos and you want to know kind of like more details about how I did this, I can make little tutorials or videos and post code snippets and stuff. So yeah, but I'm very happy with this. I think it works. This silhouette especially works really well with this outline that we're seeing here. So yeah, and I'm gonna go over how I did that now. So we have materials. Actually, I'll find lobby Torus. Terrain lobby. Okay, so the terrain mat. We have a look at this. This might be a little difficult to read, but hopefully I can zoom in. So how the terrain is rendered, and in fact this is how all enemies are rendered, they go through this toroidal hash raycast. So the idea is that for any pixel, we go get a point on the surface of the torus, and then we map that to some sort of a color function, right? So I can go into this subshader, and you can see it here. So we do a bunch of stuff to actually generate the color, so that's what this is. And once we generate the color, or the color like options, we go through this toroidal blob hue function here, and this is inside of this script. I gotta boot this up, but this is mapping the point down onto the surface, and then it's using the two colors passed in to determine the final third color that actually, or yeah, to determine what pattern effectively gets shown. So which one are we using? We're using toroidal blob hue, which is this one. So this is a HLSL file, so this is the shader files. Underscore float here on this function just means that this is using floats. Unity can either use floats or halves. Yeah. This function also manages the metables. So the metables themselves actually also modify the colors, and this goes through here. So these are global values, and these are modified during runtime. Sorry, there's a lot going on here. Let's go from the start. So I pass in a position. I determine. I have a bunch of meta balls or points on the surface of the torus at different spots, and we find which one of these has the most, is the kind of the closest, or has the most influence on our position, right? And when we find the blob that does that, we use that blob to modify both of the colors that were passed in to this whole function, right? So this so what this means is that each blob can apply a different tint to the actual to the color that goes out. And actually, in fact, that is all this function does. So this is just modifying the two colors that came in. So A, B, and then this goes to the dither mode. So we here it is, get toroidal UV recast. This thing, recast from camera to Torus. So we take the world position, we take the camera position, and we recast kind of from the camera onto the through the position onto the torus. So we draw a line through it, and so it's using recast from camera to torus, which is going to be all the way down here. Here we go, recast to torus, and this recast does it takes a few steps forwards, which is probably going to be, what do we got? Steps 3, I think. Max distance 100 and epsilon 0.1. Yeah, so it tries to step forwards until it hits it, and I could probably increase max steps, but 3 just seems to be good enough to actually get me a good accuracy. And you can see what I'm like, kind of the way that this is functioning when we look at these. So these blobs here, right? These are using the same texture or the same material, and if I look like this, right? I can't, like, I'm not. This is supposed to be like mapped onto the torus. So if we like look at the surface here, yeah, you can kind of see these ones. Swap from the map torus to the actual lobby torus. Oh no, not the lobby. We want game, and we want to hide the map torus. Is that the one? Map outline torus as well. I'm gonna hide this. Oh wait. Hello? Am I created? Wasting time. Torus. Show yourself. Ah, right. Gizmos. Okay, here we go. So yeah, you can see that this object is kind of like mapping up, and you can see that the 3 attempts can't raycast onto the surface here, so they're just kind of giving us a random thing, but it ends up looking really good at any angle, but we're only going to be looking at it like this, so that looks nice. And so that gives us a position onto the torus, so we'll position on torus, and we pass that into this get toroidal coordinate function, and so that gives us the 2D coordinate vector. So this is in radians whatever. And so that's what this is showing up here. So this is the 2D map, and so this wraps around like vertically and horizontally. And if I actually went into the game and generated some terrain here, you'd be able to see on that the stuff. This is all building up to getting to what the actual how the cutting works. So now that's been generated, and so you can kind of, yeah, you can see it up here. And so this wraps around up there, and it wraps around horizontally as well. And I think that, so this corner goes down to there, and so that corner goes over to there. And this is wrapping around, but I think the scale of this thing is a little too much. So you can think of, go all the way over to here, and then maybe like cut off the last 5%. Yeah. All right. Now back to this. So. Okay. So now we have the toroidal position. We multiply it by a scale, and then we use our dither mode. And so this is actually what's giving us the ground textures. And we use this dither function to select. So this is dither, and this kind of just selects between the two different colors that we got out of this blob hue method. And it chooses a final color. We add some rim lighting to it. So this this function takes the position, or no, it takes like the normal of whatever pixel we're at, and it determines if it's like right at the edge. This is a pretty simple method of you'll find this online, but dot product normal and the view direction. You just get the values, a bunch of stuff here. Take a screenshot of this if you need it. And then we do a few little funny things here to get kind of a nice edge color. We replace. I shouldn't be doing it like this. I should be using a color. I should be using a, where is it? Artistic. Adjustments. Blend. Here we go. I should be using a blend function to blend between the edge and the actual regular color based off of this is rim. But I'm not doing that. Apply fog. I don't know why I have fog. Anyway, so that's giving us this is effectively the color of the torus, right? Now that we actually have the surface color, what we do is we pass it all the way down here and we go to the terrain voider. So this thing is a little funny, but most of the code is done in here. So get inverse void information. So similar to the blobs, right? What we have here is in the code, I pass around the void positions and their radiuses. And this get inverse thing, what it's doing is it's determining if a point is, like, what to do with a point, given that it may be inside or outside of one of these blobs. So we find where the closest one of these blobs is. We do some funny stuff to determine if it's kind of on a split between two toruses, right? And we know that if the distance between those, if like I guess the distance value between those two toruses, I mean those two voids, is roughly the same. If it is, then we can use a yeah, so this 500 here, this is kind of like that draw radius effectively of the split lines, right? So if we have a look at this, so these split lines, right, we've got a hole over here and we have a hole over here on this side, so these two, right? And you can see that their closest line of intercept is there. So if I shrink all of these, there we go. Yeah, and you can see that the split line is like that. So that's how I'm determining where those lines are. The next thing is, here we go, only valid if this squared is less than that, so radius. So we get the distance or the value from 0 to 1 for how close it is to, or how much inside it is. So at 1, it's like right at the center. Towards 0 is where it gets towards the edge. So that's what this res value is. It's because I'm smooth stepping from 1 to 0. And so as this distance gets closer to 1. So this is going to start off at 0, so it'll be 1, because it's right at the center. Gets smaller towards the edge, and we do some funny math to determine if it's inside. So because I don't want to use as many ifs, and I'll try and get rid of this if as well at some point. Because shaders are a lot faster if you get rid of all of the ifs, and this is running on every single thing in the game, so this is not like, so this matters. This is running on like every single pixel, like everywhere. We'll get rid of that. And then I go down and yeah, so I say, are we inside? And then I also check, are we at an edge? So we're in an edge if we're in between the inner and the outer. All containing voids are edges. So anything that contains us is also an edge, right? So this was important because this is to draw this edge here, right? We're inside of 2 edges, right? So so if I draw a line over here, I don't want to draw an edge over here because I'm fully inside of this, right? So I need to remember that inside of my function. I need to say, okay, if so, we start this off at 1, and we're still an edge if something doesn't contain us. So if this res value, right, which is this thing here, if this is less than or equal to 0, then we're outside, right? Because our distance from the center is greater than r, well, r squared. Yeah, I'm squaring this. And or we're still an edge if this is false, right? Or no, this is true. It's like it doesn't matter whether this is, but we're still an edge if we're outside of the edge like circle, right? And so that's the radius minus the edge radius. And so we're outside of there. And so that gives us this, right? So that's just some funny math to avoid any ifs at when possible, right? You can just multiply by conditional, and this is faster. So then we put still an edge if everything is valid and all voids are edges. We're a split if everything is valid and the split closest index is equal to the closest index. So the split closest index is the index that, like, the index of the last thing we ran into, which was close to another void. So when we're the same distance from 2 voids, we're going to record that index. Be it the first one or the last one, we're going to record that index, and we're going to make sure that the closest thing, like if we're closer to something else than either of those things, and that thing that we're now closest to is not also a split, then we kind of need to forget about that. So if this index doesn't match the closest, like, split, right, then we're not a split. So that's why this conditional is here. And then finally, our out color is if we're valid. So if we're not valid, zeros. If we are valid and we're not an edge, we're the in color. So just maintaining the color that we originally were. But if we are an edge, instead just overwrite that and use the edge color, which is what this value is here. Yeah. And finally, if we go back to the terrain map, so that's the terrain voider function, right? So is valid, and we output that, and then out color, so is split, we're going to half the resolution, effectively. No, half the all of the colors, so fade it out, and we're gonna do like a little bit of a blend. So we're half blending whatever we took in with this value, which is the edge color, right? So I can zoom out a little bit for that. Yeah. So we go like, okay, pass the edge color in there, out color. If we are a split, so one of those lines, we're going to blend whatever our out color is with that edge color anyway. So And that's what gives us this effect here, right? We're blending it. Cool. Now finally, if we go back out here, so this is the terrain map. Yep, void color. And we also, this is the, if we're the back face, we also blend our opacity down. So I think this was a hack so that, yeah, this is, what's going on here? Multiply by not front face. This is weird. I don't know why I'm doing this for the back faces. I think this thing is only visible in the front face anyway. Yeah, so the back faces aren't even visible for this terrain map. But if we, but what does matter, again, terrain, okay, terrain map. So this one, what this does is, if it's not a front face, it does exactly the same thing, everything else. But if it's not a front face, then we're going to like halve all of its colors, and finally to get the actual like transparent thing, because this is still zeroing out stuff that we can't see. To get the transparency, where is it? Where is it? Terrain map outline. There we go. Yeah, to get the transparency, we just don't do any of those checks, effectively. Right? So, if I bring back that transparency stuff, or the map view. Again, sorry, I'm losing my mind while I'm talking, but if we look at the outline, well, I don't actually need to do any sort of collision checky stuff with the voids on this. I just always want this to get shown. It's just this map torus, right? This thing is allowed to actually have the cuts, right? And you can see it gets darkened when it's the back face. So that's what actually, this one actually utilizes that back face stuff. Yeah, so that's how that works. What the? Now, all right. So that's part one. That's the shader effects that are actually applying to the surface, and the few ones that I actually made a change to today. Oh, the last 2 days, right? I mean, I also did all the spawning stuff and the shrinking of these things. But now, if we go into the game, I can show you the portals, and you can see a little preview at the bottom right down here, right, of one of my portals. This is still a work in progress. I need to get the, I guess, systems for this done today. I gotta wait a little second for this to load in, right? But if we actually look at the scene, we can see above the character, there's this weird portal. And below the character, there's a portal there as well. So now, oh, that was a little preview. So you can see if I fall off here, a portal will open up, and I'll show where I'm gonna teleport to. And I thought this was quite funny because it's another ring in the game full of rings. That's all. There we go. That was almost smooth. So yeah, I need to fix some bugs with how sometimes it'll smoothly transition. I also have to fix the bug with the teleporting. It's just kind of ugly. And yeah. That's what I'm getting done today. I'm very happy with this so far, and it makes the game a little bit more forgiving. I think I'm going to make you take damage when you actually land from the portal. Yeah, but that's what's getting done today. And here's the final work, or the final preview of all of the stuff that I've done. And you can see that this transparency really adds a lot. It looks fantastic. A huge fan of this, and especially this rim lighting. I think it's really interesting, and it's going to be also even more interesting once we get inside the Torus. So I'm excited for that. So yeah, I'll get back onto the daily schedule soon, hopefully. All right, bye bye.